Hey, we're looking here at piecewise number 4. The following piecewise function depicts the height of a bottle rocket as a function of time where. So we start off with a parabola or a quadratic equation right here because we're starting off at the origin. And we got another straight line here and another straight line here. We know that point. We can figure out some of this point based on these things. And we want to know that the time it takes Johnny notes the time it takes for the rocket to reach a height of 50 meters on the way up and again on the way down, and how long is the rocket above 50 meters of height. So where is the rocket at 50 meters of height will be right here. There and there. In other words, Johnny wants to know what is the difference in x's between this point and this point when the x is 50. It's going to be 50 on the second function and on the third function. On this function and on this function. Now on this function, we're good to go. We can plug it in. We know when the y is 50, we can solve that. We should go ahead and do that now. So for function 3, y is equal to 50, negative 7x plus 171.5. So I'm going to subtract 171.5 from both sides of that equation. Going to get negative 121.5. It's equal to negative 7x, which you know I'm going to have to divide now. And that's going to give me 17.35, 17.36. I like to keep two decimals. Positive 17.36. So that's easy. We know that's how much time it took to get to there. But we need to do it for this one. And the problem with this one is we don't have the function. We only know that y equals ax plus b. But we do know something. We know that that first function terminates where the x is 6. In other words, we know the x there is a 6. So because of that, we're able to do some pretty quick calculations. We've got an x and a y, and do I have enough information here? Oh, I'm foolish. Of course we do. So all we have to do now is find this point right over here where we know that the x is a 6 because this is the quadratic, and we have the rule y is equal to x squared, or y is equal to 1x squared. So x is a 6 here. So that means the y is a 36. Now, what have I got? I've got two known points. With two known points, I can get a slope and I can get a rate of change. We'll do that over here. It's just straight up equation of a line now. A is equal to, I'm going to go y2 over here and y1 over here. So 70 minus 36 over 14.5 minus 6. If you're having trouble with that, you can review the linear function videos. 70 minus 36 is going to be equal to 34 over 14.5 minus 6. 8.5. 34 divided by 8.5 is 4. So we know the slope of that line is 4. Now we can go ahead and get its b by plugging in the slope that we know on one of the points. We'll stick with the 14.5. Let's use the 636. The numbers are pretty. 36 is equal to 4 times 6 plus b. So I just put that point xy in there with the slope that I figured out. It's 24 plus b. I'm going to subtract 24. And that leaves me with a b of 12. So now y is equal to, I know my a is 4x plus 12. There's the equation of my first line, or sorry, line number 2, that line right there. And now I can put in that y of 50 and solve for x. I'm going to subtract 12 from both sides. Divide everything by 4, so I went 50. Just let me check on my calculations. Minus 12 is 38, and I'm going to divide that by 4, 9.5. So what's the difference between 17.36 and 9.5? Well, 17.36 36 minus 9.5 is 7.86, rounded to the nearest decimal, 7.9.